Here's the definition of exponentiation. X to the a power means ax's multiplied together. That is, for any real number x and for any positive integer a, x to the a power is x times itself a times. And here we look at x to the a power. The x is called the base, and the a is called the exponent, and the entire expression is called a power. Here's 4 to the third power, also known as 4 cubed. We use exponentiation to write it like this, and then we multiply and we get 64. Here's a to the third power, also known as a cubed. Once again, we use exponentiation, but since we don't know what a is, we can either write it as a cubed, which is the shortest, preferred, or a times a times a. Here's a product, 2 times a, and that entire product is taken to the third power. And we know that that means 2a times 2a times 2a. And the commutative property of multiplication allows us to write it in this order. And then the 2 times 2 times 2 makes 2 to the third, and the a times a times a is a to the third. Well, of course, 2 to the third is equal to 8. We prefer to write it that way. The a to the third is left as a to the third. And our final expression can be written 8a cubed. And that brings us to something called the power of a product. Exponentiation distributes over multiplication. That is, for any real numbers x and y, and for any positive integer a, the product xy taken to the a power is equal to x to the a times y to the a. And now let's go back to our previous expression and apply the power of a product, as shown. The 3 distributes throughout that product so that we go straight to 2 to the third, a to the third. We've saved us writing all those extra 2's and a's. 2 to the third is, of course, 8, and now we've rewritten it as 8a cubed using the power of a product. Here's another expression, x to the fourth times x cubed. And we know that x to the fourth can be written as x times x times x times x. X cubed can be written x times x times x. The associative property allows us to change the grouping so they're all grouped together. We count them up, x to the seventh. But if you look up at the top at the 4 and the 3, you may notice something. 4 and 3 adds up to 7, and that leads to this rule, the product of 2 powers with equal bases. If you multiply 2 powers and both bases are equal, then you can add the exponents and use the same base. That is, for any real numbers x and for any positive integers a and b, x to the a power multiplied by x to the b power is equal to x to the a plus b power. And so let's do this previous expression applying the product of 2 powers with equal bases. We simply add 4 plus 3 and we get x to the 7th. It's much shorter when you apply the product of 2 powers with equal bases. But here's yet another type of expression. We know that this means x to the fourth times x to the fourth times a third x to the fourth. Then we know that each one of those can be rewritten as shown. And then the associative property allows us to group them all together. We count them, we get 12. Then we look back at those original 2 numbers, the 4 and the 3, and of course, 4 times 3 is 12. And that leads to yet another rule, the power of a power. If you raise a power to a power, then you can multiply the exponents. That is, for any real number x and for any positive integers a and b, x to the a power taken to the b power is equal to x to the ab power. And now let's put that into practice with our previous expression. 4 times 3 is 12, and there you have it, x to the 12th power. And now let's do one example where we try to bring just about all of the rules previously stated into play in one problem that we're trying to simplify. We start by applying the power of a power. And we use the red marks to show how we're going to proceed. And of course, the n doesn't have an exponent. So you could think of that as just applying the power of a product. But these 2 rules are so closely related because n is the same as n to the first power, and 1 times 3 is 3. So if you want to just think of it as the power of a power, that's fine. And here's what we get. We have a 1 times 3 to get the n to the third. We have a 4 times 3 to get x to the 12th. We have a 5 times 3 to get n to the 15th, and a 2 times 5 to get x to the 10th. We apply the commutative property, and we choose to write our variables alphabetically. We have the 2 powers of n together and the 2 powers of x together. And then we apply the rule product of 2 powers with equal bases. And in terms of the powers of n, that's 3 plus 15 is 18. For the powers of x, it's 12 plus 10 is 22. And that's just about as simple as we can get it for now. N to the 18th times x to the 22nd power. Here's a summary of our 4 rules from this lesson. Exponentiation, power of a product, product of 2 powers with equal bases, and power of a power.